All right, now whose idea of a good time was this? Probably yours, right? No, it's mine. This is probably the hardest type of problem you're going to do in the heat transfer video. If you can do this problem or at least kind of follow along with the initial setup, any other thing I ask you is going to be kind of easy. So let's go ahead and get to it. You've got two substances mixing and they're going to play together. We're going to have to do some calculations based on what we know from the lab. Okay, you want to warm up some bath water that's currently at 20 degrees. So this is your T initial for water with a hot block of marble that has a specific heat, 2100 joules per kilogram degrees Celsius. So this is your C marble, and a temperature of 90 degrees Celsius. So this is your temperature initial marble. If the mass of the water is 20 kilograms, so this is your mass water, and the mass of the marble is 25 kilograms, so this is mass marble, mass water, mass marble. What is the final temperature, T final, of the bath water at thermal equilibrium? Okay, what you need to remember is that the T final for both is going to be the same. So T final water is equal to the T final of the marble. Okay, so watch this. Remember from lab that if I have a hotter object, its Q is going to be negative. It's going to lose heat. But that cannot be lost into the ether. It can't be lost into nothing. It has to be gained by something else. So in this instance, the negative Q has to be equal to the positive Q gain of another object. So the heat lost is equal to the heat found, heat gained. Okay, so which object is going to lose heat? The hotter one, right? So which one's hotter? The marble. So the energy lost by the marble has to be equal to the energy gained by the water. So watch this. What's Q equal to? MCAT, right? So negative MCAT, we get to bring the negative down, equals positive MCAT of the water. Okay? So let's go ahead and plug these guys in. This is where it's going to get kind of dirty. Okay? All right, so my marble is 25 kilograms. My specific heat of water is 2100. My change in temperature is T final minus T initial. You don't know that, right? Okay. My mass of water is 20 kilograms. My C of water, 4180, just like from the other problem. My change in temperature is T final minus T initial. Okay, this is where it's going to get really messed up. Okay, so I'm going to multiply these together on both sides. Okay, so let's go ahead and do that. 25, it's negative 25, right? Times 2100. Okay, so this is going to be negative 52,500 times T final minus T initial. Okay? It's equal to, multiply these out, 20 times 4180. We get 83,600. And this is where your algebra is going to get put to use. Okay, so now I'm going to distribute. Remember, if you have like this little parentheses here, you take your outside value and you distribute them. You multiply both, right? Both of these. Okay, so for negative 52,000 times T final is negative 52,000. Easy, right? 500 T final. And minus times a minus is a plus. So what was my temperature initial? My temperature initial was, for the marble, 90 degrees. So I'm going to plug a 90 in here. All right. For negative 52,500 times 90, negative 90, right, is 4 million, I'm sorry, 4,725,000. Okay, now do it on this side. Distribute. Okay, and positive times a negative is a negative. And what was our T initial of water? 20 degrees is 20 degrees, right? Okay, so 83,600 times 20. Okay, we get 1,672,000. All right, good. Okay, so now I'm trying to solve for T final, right? So I'm going to get my T finals to one side, and I'm going to get my numbers to the other side. Okay, so let's add 1,672,000 to the other side. Right? Whatever I do to one, I do to the other. Make sure to add to like terms. Remember, this is like bananas and apples. Can't add bananas to apples. So add 1,672,000. And what do we get? Okay, so this is going to come down. 4,725,000 plus 1,672,000. You get this really big messed up number. Okay, we get 6,397,000 is equal to 83,600 T final. Okay. Okay, now I want to move my T finals to the other side. So how do I get rid of a negative 52,500 T final? Add it to both sides. Whenever I do to one, do to the other. Okay. That goes away over here. I get 6,397,000 is equal to, and we add these bad boys up. It's a lot of algebra and math, but it's not too bad. You just have to keep track of your numbers and make sure you label. Okay, add 52,500. Okay, and we get 136,100 T final. Okay, how do I solve for T final? It's multiplying, right? How do I get rid of multiply? Divide both sides. Whenever I do to one side, do to the other. That's why we practice this stuff all the time, so you can do these harder problems. Divide by 136, 100. All right, we get a final temperature after all that work, 47 degrees Celsius, which ends up being about, let's see, ends up being about 116 degrees Fahrenheit. Okay, so 116 degrees Fahrenheit. You don't got to worry about this conversion right here. This is our T final though. Okay, so this is a pretty warm water, right? So you could do this by putting a hot stone in your water, but it has to be a pretty heavy stone. It's like 50 pounds, more than 50 pounds. All right,